So, hi gentlemen and ladies. So this is our 8th, I believe, event that we have done over the last 2 years. And this year we have done one more just a few weeks ago. It was led with reactive programming by using akka, programming akka framework. So this group is actually a meetup group called South London IT Professionals, and the aim behind this group is to actually connect the IT professionals living in London, especially in South London, but it doesn't matter, obviously. We are welcome for anyone. And organize these kind of free IT seminars and do knowledge share between us, and also do networking as well, so that we can collaborate and maybe share articles, job advertisements and things like that in our meetup group. And also, hopefully, we are planning to arrange more events outside this area. Like, for example, when the weathers are nice, hopefully we'll go out, maybe have some dinner or breakfast, something like that. So that is the aim behind this group, just to increase networking and do knowledge sharing amongst us. So today, my friend Ramazan will be doing the introduction to cloud computing by using AWS, Amazon Web Services. So, yeah, thank you very much.
Can everybody hear me? Is it okay? Maybe you can come forward. That's better because my voice is not that strong. Yeah, my name is Ramazan. I was originally a Java developer, but in the last 4 years, I focused on more cloud projects, and I set up my own company a couple of years ago. We are now AWS consulting partner. We are working mainly startups and small medium enterprise and doing cloud migration projects. I'm going to talk about today general cloud computing, what it is, and why Amazon is the leader of the market at the moment, and giving some examples, startups, successful startups on the cloud. And after that, I will give you some overview of core AWS services. Everybody hearing me well? If you start agenda, I already explained the agenda. So I'm going to start off with comparison cloud traditional computing. So cloud actually now become very popular. Who is using cloud at the moment at work? 1, 2. So have you used any cloud provider in your personal projects? So everyone knows it. Then there is no need to presentation. Yeah, if you compare traditional cloud computing, normally if you are starting a business, you need to buy hardware, set up all the hardware, you need to buy the equipment. You have to spend up certain amount of money for the certain hardware equipment. But in cloud computing, the argument is you don't need to spend this amount of money. Just rent from the servers, virtual service from us, or any other services related to cloud. So you can actually pay as you grow. So which makes sense. In the traditional computing, actually you need to retain IT staff to look after your hardware. But obviously, there are different business models. There are some small companies where they can put a couple of servers in their single server room, and a developer, actually a networker and database and everything, looking after servers. But more, when the company grows, actually you need to actually maintain lots of hardware and look after and retain more IT stuff. But in the cloud computing, the argument is you need to focus on your business and actually outsource all this work to the cloud, and actually you save money. One of the, for me, the biggest difference between traditional computing, when I say traditional computing, I mean you can actually set up your own data center as well. It's a big job, but some of the companies doing it. Biggest difference between cloud and traditional, actually cloud computing allows you to automation of the process. Where in the traditional computing, most of the process is manual. It's I think one of the biggest difference between cloud and traditional. You can say, you know, now people actually rent servers from the data centers as well. They don't need to set up all hardware. Actually, you can get virtual servers from the data center. You don't need to go a cloud provider. This is another argument. But where the automation comes into picture here, they give the servers pictures, but actually it's very basic service. But in the cloud computing, they provide automation and much more services than a traditional data center services. We will discuss it in more detail in the coming slides. One of the other advantages of cloud computing is multiple data centers is very easy, whereas the normal traditional data center, generally you use only one data center. There are cases that, yeah, you can have multiple data centers, but it's not that easy and very expensive. But in cloud computing, even you are just startup, you can actually create a website or mobile app and actually deploy in the whole world more than one data center in just a couple of hours time. That's very, very easy. In traditional computing, normally when you have more traffic or more users coming, you do vertical scaling. You get bigger servers. But in cloud computing, you can actually utilize the cloud computing horizontal scaling, which actually result of the automation.
So, can I ask a question?
Yes.
Or later?
Not the difficult ones.
What? How does it relate with automation? How is
Automation.
it related with automation? The
Yeah, actually
horizontal scaling.
I will show you later. Slowly. So when it comes to cloud computing, there are main three categories. Infrastructure as a service, platform as a service, and software as a service. These are the main categories. Some of the people coming up with different low-level concepts, but these are the main three concepts. Infrastructure as a service, as you can understand, you get the basic virtualization of the servers, storage, or network appliances. In the platform as a service, it is one level above the infrastructure as a service. They try to get you away dealing with this kind of virtualization or everything. They say we can give you the platform. Example, there are lots of examples on the past. For example, hosted database, for example, MongoDB. Either you can hire a virtual server, you can install MongoDB, you can do all the maintenance of work yourself. This is infrastructure as a service. In the platform as a service, actually you say, I need 100 gigabyte of storage, this amount of request, I want to process this, you just give request, they give you MongoDB as a service. This is called platform as a service. You can give databases or APIs or system backends. There are many variations of the platform as a service. For example, Heroku. Heard of Heroku platform? You just write your application, give it to the Heroku, they say we will take care of all the scaling and everything. This is platform as a service. They give you tools, languages, you just develop your application. They take care of all the work. For another example, for example, Salesforce. It's a CRM application. They got their own language, their tools, you design application on Salesforce platform, but they run the whole platform. Software as a service is high level. We don't actually develop anything, we just use as a software, like Gmail. Gmail run on cloud. AWS today mostly recognized by infrastructure as a service, but now moving lots of towards the platform as a service and also provides software as a service. Actually, they matured their business on the IaaS side. They saturated the market. Now they are looking for more money from PaaS and SaaS. Actually, I have been following this cloud space for a long time. First time I started with Google App Engine back in 2010, which is a PaaS. At that time, they were running Python. That started Java later. I spent every time on Google App Engine. After then, Google disappointed me. It didn't work out. They failed to attract business to PaaS because it is lots of vendor locking concepts. So people actually don't like binding themselves platforms. So AWS actually realized this point for a long time ago. They started 2005. So they spent all their efforts on infrastructure as a service. After getting the market, they started the PaaS. Now Google started from PaaS. Now they are moving to infrastructure as a service because they couldn't make money from PaaS so much. So in every category, you can find providers, cloud providers, different tools, and different concepts. Everybody define their own concepts. So lots of buzzwords going on.
One easy question.
Easy question.
Yes. The difference between the first one and the second one. Couldn't catch quite. What's the difference?
Difference, we have hardware.
The first one, yeah.
Yeah, first. And there is a virtualization layer. Hypervisors, KVM, lots of different technology. And on top of it, cloud providers has softwares to efficiently sell the servers virtually. So in this layer is IaaS. So you say, I want to have 1 CPU, 8 GB of RAM, this blah blah blah, this server. They give you these servers for kind of a certain period, couple of months. This is IaaS. So there is no software, nothing. So you have to build your software yourself. In the past, you don't talk about servers, CPUs, whatever, networking. You say, I want a platform to run my application.
In Google,
This virtual machine.
Clear?
The first one is.
but
The first one is virtual machine, right? On the cloud.
Yeah, this infrastructure is virtual machines, virtual networking, everything is virtual, storage is virtual. But you have to deal with this kind of low-level details, like networking. For example, load balancing, DNS names, everything. You need to set up yourself.
May I make a comment? Just subject to your confirmation, if I understand correctly. Actually, the difference between IaaS and PaaS could be more apparent when we differentiate between SaaS and PaaS and leave the rest to IaaS. SaaS being for use of more for the end users outside corporations or inside corporations with not necessarily IT department users. PaaS being actually for the purpose of use of more technical guys to build up more software for the end user, for those who are actually building their software for the end users, and the rest actually the hardware.
You can say that, which,
if you buy PaaS service, can you specify that I want to this software, this framework in my server, because every product might have different specification, different framework that means the dependencies.
like I said, platform as a service, there are lots of variations.
Yeah.
But if you look at Heroku, it is running on Ruby on Rails. They started with Ruby on Rails, so they expect to run Ruby on Rails framework. But after that, they started Java, I think. But Java, there are Java solutions. They say, you give us your, for example, we have artifact called jar or raw file, and they say, we got containers installed. we actually optimized it for you. You don't need to think about the application content optimization or anything. You just give your artifacts. But there is a term called here 12 factor. You have to design your application based on 12 factors. You have to give logging and other kind of metrics so the platform actually understand your application is running. There are kind of 12 factors. I can give you the links later. But lots of variations. So maybe some of them doing the like this, they are giving frameworks like this. You are developing your application based on frameworks. Some of them, like I said, ask for the just artifact. They just run the artifact. So there are lots of variations. Even there are open source.
So it's not fully flexible actually. So you have to tie it with the existing
Always.
configuration.
Yeah, there is nothing free. So that's why Google App Engine didn't take off. They said, well, actually you are using Google backend, big data, big queries that time. We will do indexing everything all over the database. You just write your application. But when you look at organization, everybody has come up with different requirements, everything. So people doesn't like to fit into some certain pictures. So there are already restrictions with the past, but some people find it easy. Heroku, lots of Ruby guys develop lots of application on Heroku. Heroku is one of the good startups, I think, in terms of platform as a service. For example, APIs, you can sell APIs. It's not only application development. You can, for example, Google Analytics, right? They just provide APIs, endpoints, and you use it from the browser, send metrics. They say, 1 million API is $5. This is a platform for them. So as long as it is one level above the virtualization, and giving.
Can you specify also performance? For example, I want to this much RAM. I want to make my surface faster.
Yeah, lots of definition. For example, in Heroku, you got Dino. You say I want 5 Dino workers. So there are abstractions for pricing and power, but you don't deal with CPU level and memory and everything. So of course, because abstraction based on the CPUs, but they just hide these and details. Even you can now, there are open source projects, you can download frameworks and you can run your own platform as a service solution. One of them is Cloud Foundry, which is pivotal Spring tool. You can try. Their claim is the same, don't deal with building servers, etc. We care of this business. You just run your application, we will run it, scaling and everything. This thing I think not working very well. I mean, people choosing infrastructure as a service mostly. But in here, I think people making money from like hosted databases, hosted business intelligence solutions, more kind of service solutions rather than whole platforms. It is selling more. AWS, for example, now providing gaming engine hosted. So they see one.
Can I ask a question?
Yes.
Maybe you said it early, but maybe I should wait at the end, till the end. But what kind of services AWS provides as a platform? Because Google App Engine, for example, contains big data, SQL, endpoints, Google endpoints, and some other kind of platform level frameworks. In addition,
it's a good question,
Yeah.
because it is my next slide. Can I have water, please?
Yeah,
sure. So, AWS started 2006 actually with S3, simple storage. But their project started 2004. Maybe it's hard to read.
I saw it.
I'm going to show you here. I'm going to tell kind of stories. Things. So this is the flow. This is the guy, Jeff Barr, is evangelizing AWS. First blog is 2004. He said, welcome Amazon Web Services. They started actually 2004. It's kind of internal project. This is his last blog. He hasn't died yet, but he's still alive. So 14th of March 2016, he says, we are celebrating 10 years of AWS. So practically they started 2006. But most visibly, their flagship product, EC2, Basic Virtual Servers, started in 2008. Started from 2008, now coming, every year they added lots of services. It's amazing, they spend lots of money on these, lots of resources. It is one of the Amazon business actually strategy. They do long-term investments. For example, the bookstore, Amazon started as a bookstore. After that, converted into the e-commerce business. And they haven't made any profit 10 years for e-commerce business. So they put lots of long-term vision. So when they started a cloud business in 2004, probably, or they said like 10 years, we will be investing all the money. But focus on, because they see the trend is going that way. You can ask, how these people can see, this kind of things happening, it's another thing. If you think about it, essentially this is kind of clustering. You got hardware, you are actually virtualizing and clustering, and you are actually distributing work across the hardware. So lots of big companies already have been doing clustering and virtualization, but they are doing it privately. Because it is complex business, and if you think about like 90s, 2000, hardware is not capable enough, doing lots of virtualization. But after 2000, advance of the hardware, and also there's a limit in C2, so you can't advance speed of the C2 anymore. So they focus on more clustering. So they see the future is coming with this cloud computing clustering. They start to go into 2004. Start as an infrastructure as a service, Kemal, like your questions. These are, 2010, elastic load balancing is load balancers, virtual load balancer. This is, again is infrastructure. Auto scaling infrastructure, VPC, virtual private network. This is infrastructure, but in here, RDS is actually relational database. So they started the PaaS 2010. So focused on infrastructure, but also they realized there is a potential as well providing services. So they started RDS and EMR, Elastic Map and Reduce framework based on Hadoop, but at that time maybe they were using another framework, I'm not sure. This thing is infrastructure. And next year, for example, this Elastic Beanstalk is PaaS, like Heroku. You give your Java application, and Amazon says, I'm gonna do all the scaling, don't worry about it. But it's not really PaaS, it's kind of abstraction, I know the details. But they said, if you want, I can manage your underlying infrastructure. But it is not 100% PaaS like Heroku and other things. So actually they started PaaS as well back in 2010, and because infrastructure space already there's a limit, they are improving services, but they say we can do the business as well. So coupled with PaaS and come here, going more SaaS as well now. SaaS, you can give different definitions, but this code deploy, code commit, and code pipeline is actually basically code continuous integration tools and continuous discovery and delivery tools. It's not exactly infrastructure or anything, but they are actually renting software. You can rent Jenkins from hosted service as well. They have now email as well, like Gmail, AWS email, which is, you can say, is us. So, rapid pace of innovation. Good thing here, 47 price reductions. They always reduce the prices. You expect like increasing prices, but their argument is we had less customers beginning, which was expensive based on per customer. Now we are getting more customer. Story is Microsoft and Google also going into picture, so competition started. But they say more marketing word.
Since when is this 47 price reductions?
Always reductions. They start like 2010.
What's the 47 percentage?
Sorry?
What is it? Percentage, 47 price reductions.
47 times. They announced.
Redacted already.
Yes. Yeah. I mean, there are lots of services as well. For example, they say, okay, we are reducing S3 pricing now. So it's an announcement. So they got already now over 50 major services. So if they reduce one by one, just 50, they are not decreasing a lot of, but I can see that the EC2 pricing come a lot because Google actually playing a bit very low because they don't get any marketing share.
Can I ask a question?
Yes.
In Google App Engine, for example, it doesn't support Java 8 and Lambda expressions, which is a new feature that's introduced in Java, new version of Java. And also it doesn't support integration with reactive platforms like Akka, so you can't use push mechanism to the client actually by using Google App Engine. Does AWS provide solutions for these? Like, does it have Lambda support, Java 8 support, and
because it's the infrastructure as a service, they don't care which version you are using.
yeah.
That's what I mean. If you want to use Java 8, Java 9, rent a server and it's for yourself.
Just pay for it.
Yeah.
Google
But
Service
Elastic
do not-
install.
Yeah, Google
But
Service
it's a very specific question. We can maybe talk after the talk, because we don't have so much time. It is one of the restrictions of platform as a service. They have certain restrictions. So basically, if you want to provide platform as a service, you can't always restrictions. So that's why you can't make money so much. If you pass, people, say always cautious. So if you think about infrastructure of AWS, so AWS has data centers all over the world. Things called region. So these are the regions. Each region, they have more than one data center, which is called availability zone. So region actually not data center, but the location in the world. So this is a very important concept. So in each region, there are some regulations and certification about this. There are minimum 2 data centers, and they have to be located at least, I think, 100 kilometers between each other because of disaster recovery purposes. If there's an earthquake happens, they want to save one data center. So this kind of things require certification and regulations. So we don't know this kind of low-level data center regulations so much as a program. But if you go into the business, there are lots of regulations, certifications. AWS has, I think, over 200 certification around their data centers, quality, security, disaster recovery, different purposes. Good thing about availability zones, even they are located very far between each other, they got very high speed of connection, fiber, or if there's better than high fiber technology, there's a high internet speed between the availability zones. So they are actually very close. You can put a cache in different zone, you can put another API in different zone. They can communicate very well. But there's a ping time, obviously. So, what is the benefit of having regions all over the world? Anybody? Idea?
They can redirect the traffic based on your
Yes.
location.
Yes, I think it was one of the difference between cloud computing and traditional data center. Traditional data center generally located in certain regions, and they target market around the people. But now, in the last 10 years, people start up, and they wanna go on by all the customers around the world. So then you need replicated data and everywhere, because if you are serving only from this, for example, America, and if you got customers China, 1 million population, India 1 billion. So traveling time between data centers affects your quality of your services. So for example, I measure myself between data centers. It may vary, depends on the time, maybe, I just there's a sabotage. From if you send a ping request from here, East America, and if you send ping request from here to East is in West America, it's around 100 milliseconds. It's just ping, very lightweight.
From where?
East of America.
East of America to where?
To West of America.
Okay.
Just here, 100 milliseconds.
100 milliseconds.
You saw what I mean? Even within America, if you send like pictures and everything, it affects, if you have lots of customers. It actually puts lots of pressure. If someone comes from here, browser, clicking on your page, download the picture here. Okay, coming. So it affects. It's one of the aspects, people want to deploy data centers here. For example, between London to East America is faster. I don't know, maybe there is no geographical area, trunks going under the ocean. Europe and Turkey, for example, there is a lot. Maybe there are lots of pop points, I don't know. But there are these kind of things. So availability is also very important. Amazon is spend lots of money making things very available between data centers. It is very hard business for cloud computing. Thousands of servers running. You are replicating data across data centers. Very difficult. So it is actually one of the cloud computing as an advantage. Someone already spent lots of resources make it happen. It's not easy deal. And
that was me. So I was going to ask about, back in the day, people had data centers and then they were relying on CDNs. I think that was the content delivery network, like Akamai. So they would just have a data center and then use Akamai services to distribute this whole workload, or whatever the role is. So how is that playing against the CDNs now? So is Akamai dying now?
If people doesn't know CDN is actually static.
Is it?
Static files.
Mm-hmm.
Yeah. You can serve static HTML web pages, but very simple. But CDN is for movies, JavaScript files, maybe libraries, just for downloading purposes. AWS has different service for this. It's called edge locations. I haven't shown it here.
Mm-hmm.
Amazon has separate edge locations around 50. So I'm not considering as part of this talk edge locations. It's not important. This service named CloudFront. So even edge locations in everywhere, Africa, South Africa, everywhere. It's not a big deal. This is for more application development data centers, available news. Akamai already is number 1 in CDN. So Netflix story on AWS, very important. AWS already very publicized this Netflix use case everywhere. Marketing, music, we work with Netflix, etc. When I started 2012, I was reading about Netflix stories, and at that time I started using AWS. I said, these guys, business guys, Google, actually, I was right. Google actually really, they produce really high-tech products. but I think they fail to understand business. Amazon guys is business guys and also understand technical technology very well.
You are saying Google doesn't understand business.
Hmm?
Well, right. You are
Everyone knows Netflix?
No.
No? Netflix is a streaming service, video, movies, films. Now they are actually, you can see how serious they are. They are genius guys. Actually, they disturbing existing business, which is TV. They say, I don't want to watch TV, but I want to watch something whenever I want, on demand TV. So they really disturbing business. Now people watching movies, programs, and even Netflix now, they are doing their own TV series, only available on Netflix. Yeah, so actually now actually they are media company. Very interesting. Netflix originally actually renting DVDs. You just rent a DVD, they send you by post DVD, you watch DVD, send back. So around 2007-8, they said, this broadcaster business, it's not gonna work because internet is going fast, and we can start streaming business. So they decided to switch to streaming business that time. They are up and running company, profitable company, but they said, we are changing our focus. So it is competitive market. This is America. People changing all the time. So they made a very serious decision about cloud computing that time. They said, we will start on this business on cloud. Where is actually it's a big gamble because they got money. They can find investment. They can set up their own data centers. They are not usual startups, data money, work in the garage. They got money. But they said, what is the point of data center? Setting up all the data center, why somebody else is doing this business, so we can focus on business, our business. So it is my first slide, comparing, focus on business, IT stuff, whatever. But interesting thing here, they decided to work with Amazon. One of the reasons is Amazon, they said they have very big business and they know their strength in business and technology because they were number one e-commerce business in the world. They said, they are doing really business and they are actually spending lots of resources on money on cloud. We never compete with these guys, because they spend all the money, billions of dollars on data centers. Probably they will make number one because they make the e-commerce number one. So it was their theory. But interestingly, Amazon was doing streaming business at that time. Lovefilm.com, if maybe someone. Lovefilm.com the same. Renting DVDs.
They were also renting DVDs.
Yeah, renting DVDs and starting streaming. But
UK business.
yeah, it's very interesting. It's a rival. You are actually hosting your business, and you will have meetings, because you are early customers. There's a possibility they will know your business internals, what your plans, what you want. But it's, I think it's a success of Amazon as well, gaining this kind of customers. I don't know what kind of deal they make, but I think it shows, why Amazon now leader in the market now. They understand the business. They can attract this kind of people.
Not just that now, Amazon Prime movies is, for example, capturing some of the business of Netflix at the moment.
Prime is actually formerly Lovefilm.com.
Yeah, Lovefilm was
They
a
changed.
UK company.
Yeah.
Actually. Amazon purchased that company.
Yeah, I read this kind of stories every day. So, which is interesting. So they start on working on Amazon. But because streaming business, they got CDN as well. Netflix keep this CDN separate. It is out of discussion. But anything other than CDN was on the AWS. So they start to move on 2009 to cloud and moved infrastructure mostly in 3 years time to AWS slowly. They are very pioneering company. They open source hundreds of libraries, tools on the cloud. How do you work with cloud tools? So they are very innovative and actually always pushing AWS. You know, we want this, we want this. And actually AWS responding. So that's why they become number one. Around 2013, they were running like around 10,000 servers on the Amazon infrastructure. Now $42 billion, probably, I don't know, over 10,000 peak times. And this is interesting as well. Whole America's 1/3 of internet traffic consumed by Netflix on the peak times. So all services running AWS. This is what I mean, this is their big business. So these guys has got money, 2010, they say, no, actually we don't know, we're gonna be like $1 billion company or 5 billion or 10 billion. So what I mean, in the last 3 years, following 3 to 5 years. So you don't know actually what kind of investment you make in the hardware side, you know, how many data centers and where is the location of data centers, where is the regulations around data center, lots of things. They said, you know, give it to somebody else, focus on your business. Yes. They actually pioneering microservices architecture as well in the software side. Their architect, Adrian Croft. The reason they choose the microservice architecture, or they invented, maybe, probably, they said, so we don't want to deal with hardware, and we don't want developers to deal with hardware. So they remove the operations and make developers responsible for the services. So, you know, the small chunk of services, microservices. They said, you develop this, you build, you run, you solve the problems. And they develop lots of patents around cloud. You can search for Netflix OSS, open source software. There are lots of tools. One of the things, for example, I love about them, for example, availability zones become major because of these guys. They were running their systems and they developed some libraries to kill servers randomly and check the metrics whether the system is operating properly. So they were doing enormous testing. The project called Chaos Monkey. It's run, you give one availability zone, it just picks random servers, kills UI, backend database, doesn't care. And after that it checks the metrics whether any services is affected by this killing. I think they are doing it in production as well. In production they are killing service randomly. There's another library, I think. So in terms of testing of application, they are going extreme. They are, in terms of using cloud, they are going extreme. So this company is really, kind of very, very good company. 2012, I was reading these stories. That's why I chose AWS. Now I am telling stories. So cloud actually useful for companies. Why you deal with hardware? Somebody already inventing and thinking about what should be done in this area. So you just focus on your business. Another Heroku, for example, platform as a service, is a cloud provider. It's running on AWS. Even they choose AWS. They said, no, we don't want to deal with hardware even ourselves, right? So they're still running on AWS. But I think they didn't take off as Netflix, you can say. So that's why I choose Netflix. This is the history bit. Running out of time. I'm gonna give a bit
We have
quick. I'm
we have 45 minutes.
I will try this. So let's have a look services quickly because it takes time. So I'm gonna show you now on the console. Here. So this is the AWS console where you can manage your resources. List of resources. I can give a talk every week. It will take at least 1 year. You can't finish it too much. So we will just look at today basic virtual systems. So I'm going to show the EC2 basic system. So in here you can launch new servers, new server instance, and you can define your network elements, security options based on your servers. And you can do your auto scaling as well. I will give example later. So let me do a quick show you. So running a server, you need to choose an image. Everyone knows what image is, right? Based on the image. It could be Windows as well. So here is two Microsoft Windows servers. We choose Linux. Amazon maintains basic Linux for you. So you choose an AMI and you choose your CPU type, memory, networking options. This is actually infrastructure as a service, basic. So you have a type of servers, memory type, how much you need, you just choose. And in here there are actually types of family types. So first initials shows the family type. T1s very basic servers, M1s memory optimized, there are C1s compute optimized. One of the things here Amazon did, if you look at the when I choose this M4 large, it shows here 6.5 ECU. ECU, elastic computing unit, they don't give you speed of the CPU. They say we are abstracting as an ECU because during the times we are upgrading our hardware. Maybe you can get faster, but we are doing our pricing based on ECU. So you get consistent performance when you choose ECU. When I started, there were M1 series, so they upgraded M2, M3. Now we got M4. So they continuously updating series. So you choose one of them. So let's choose a moderate one, 40 virtual CPUs, 160 gigabyte of RAM. You choose which network you want to run this application. And basic storage, when you say review and launch, they say we're going to charge you, for this if you press launch button. There is no partial charging. When you start 1 hour charge, so there is a pricing for each server type. You see, 5 minutes, you are a starter, you got server, no contract. You don't need to sign anything. I attended an event in Turkey last year, a technology event. One company was claiming like they are doing cloud as well. Actually, they are running traditional data center. I spoke to the guy. I said, I got customers. Maybe I can recommend your services. Blah blah. How we work. He said, you give us like list of hardware you need. We will come back to you with price list. And we will sign a contract. I said, wow, cool. Run away. So it is like when you say traditional. It's traditional. Who cares sign a contract or whatever? So you choose the server, test, run, write, oh, I didn't like it. It's a bit much for us. It's expensive. I'm gonna change. So this is EC2 instance, basic server. There is a 3 type of pricing in EC2. On-demand pricing, like I did. If you go choose a server. Hourly charges, so there is no time limit. So in reserved ones, you say I want to use this server at least 1 year, so they give you a reduction around 30-40% of on-demand price, which is very good. There is another pricing, spot instance. Spot instance different than the other ones. Actually, Amazon think about data center they are selling the capacity on demand and reserved, and some of the capacity idle, not being sold. And they say, okay, we are selling this in auction. You bid for unused capacity.
Is it resellable?
Yes, people was doing it, I think. But spot is this, the thing is like, eBay, right? They say, oh, I'm selling this item, how much you want to pay? I would say like £7, £8. So you, for example, in eBay, you put like up limit, like, oh, I can pay £10. But eBay doesn't place £10 immediately, right? So they look at the current price, for example, let's say £5. They place like 5.5, right? So spot is the same. AWS asks how much you can pay.
But how do they know how much resources are idle by that time?
There is no guarantee.
Is it statistic?
No, you make.
So like the charter flight?
No, you make a spot request. You stop them, there is no guarantee you can get spot. So on demand.
But I'm setting up my business.
Yeah.
I'm relying on that, so then they may not provide it.
You will bust because no one can do spot instance. So,
but who can use it? That's the reason.
Look, for time insensitive or transit workloads. For example, you are doing batch works, right? You are doing some calculation.
Okay.
You don't
care about
it. You don't want to pay on-demand prices. So you say, if there is a spot instance available, when I go home, start it, do the calculation. I want to see in the morning. For example, the projects I work on, I use spot instance for example, development environments. I said, if it goes, I don't care. So the thing in this spot, I don't know, Microsoft Azure provides the same capability or Google Cloud. I never checked. But very interesting idea. In this spot instance, there is no guarantee. If someone pays higher, they take you server immediately.
Oh, really?
Yes. So it is, it's
Maybe I'll give a better bid,
It is Amazon, man. This is businessman. It's American guys, right? So very interesting concept. I was gonna show there are more interesting concepts coming with sport.
EC2 standing for?
Sorry?
EC2 standing for what?
Elastic Computing 2.
Cloud.
No, Elastic Computing Unit. I don't know this thing.
C2 is actually CC, which means C squared.
Yeah. C2 is cool.
EC squared.
CC is not.
So let's look at the support requests. Okay. So I am running a couple of support requests for this presentation talk. So I will collect money and we are going. So pricing history. So for example, you say how much is the M4 for X large? How much people paid in the last 2 weeks? You see?
Is that per hour?
Price, yes, its price is fluctuating. Let me check here EC2 pricing. EDU is new technology. I'm gonna invent it. And for
Downstairs was HSBC, right? Was somebody robbing the bank? Oh,
So, so M4 for extra is 90 pence per hour normally. Yeah, 90 pence. Look at the spot price. It is around 10 pence. So these are the available zones in the same region. Price can be different because stupid people doing the same thing in this one zone. So use your brain and put your bid in here. Look, people. It happens. Maybe they are doing it on purpose. I don't know, but So each data center sells its resource separately. So you can get this pricing differently. So 10 pence, 9 times cheaper. Very, very strong servers.
Is it per hour, you said?
This is per hour. So there is no guarantee you can retain the service as long as you want. Actually, they changed the policy this year, and they said, we will give you 2 minutes to clear up your work. So they sent event your server, so you receive your event. For example, Akka, you get jobs, you say, okay, I'm not accepting any jobs anymore. Trying to clear the jobs queues, and which is good, better than nothing. I suffered a lot, service going, start again. Actually, I use this for reliability of my services. For example, development staging, I set up on the spot, and service continues going down. And I said, okay, our system is still reliable or not. I was in double purpose.
You can immediately switch to another pricing scheme at the end of the spot period.
This is, you make a request, it's put in the bid system, so generally it takes longer. So that's why they say insensitive. So what people do, all this information available as a web service, SDKs, you can use your credentials, get this information. Netflix kind of guys, what they do is like they check pricing and whether they make a decision whether they can use spot or on demand. They do.
They have a separate department
Yeah.
for it, most probably.
And people do. Amazon open this kind of things, use me, if you utilize me better, it is good because I am giving customer better deal. So very interesting. I love this function.
Can you give us an idea about the server that you choose there? Is it enough for the mid-sized company for that, for example, for that price? Or what kind of server is it? Is it for just personal usage?
This is I think you need to do your testing, understand. But M series is moderate servers. It's okay. C1 is a bit better. Compute optimized. Because everybody has different requirements. That's why they say memory optimized, compute optimized. There is also G series, graphical unit. If you do like graphical computation, you use G. And there's another one R for intensive researching kind of, for example, you are doing kind of science project. They use this kind of high calculation speed service, very expensive, $4 per hour, $100 per day, $3,000 per month, just one server.
So, a weird question, maybe very, very short answer is enough. Can you attach your hardware, handheld hardware, to the Amazon cloud and let Amazon or request Amazon to manage it as a platform for you?
Next slide.
Maybe 10 years later.
Next slide. Yeah.
Why would you do that? Why do you need that?
Yeah, I know. People were doing it.
No, hybrid you mean? You can use on-premise and cloud together.
AWS started.
They call it hybrid.
AWS started new service this year, dedicated server. So you actually own whole server. Yeah. So instead of servers, own box. Yes. There is no. It's called multi-tenant. The cloud systems called multi-tenant. In the same box, there are other tenant application. There are some strict, for example, government application doesn't allow
Single tenant.
I don't want to share.
payment systems, blah blah regulations. They say we can only have whole
That's a dedicated
array
server, yeah.
or rack. Needs to belong to us, blah blah.
But that is still in the cloud, it's not on premises. For example, can you connect your data center? Let's say I have a data center in this building and I want to connect this with AWS.
You can.
Okay,
Yes,
so I can do it.
Yes, it's called gateway, VPC gateway. Move on quick. CloudWatch is AWS gives you metrics and tracking information about your resources. For example, EC2, you want to know like whether your CPU is utilized, discrete, networking, this kind of information, all the metrics, any resources. Well, today we just see the EC2 ones. So CloudWatch gives you information about EC2 more. Let's look at here.
Can you compute notifications? Like if my CPU utilization goes down to 30%, notify me so that.
Have you read my slides? You are always asking questions before the slide coming.
That's right.
Coming.
Just another way of saying let's proceed.
Yes.
Kamal's way of saying it.
Yeah. This is CloudWatch monitoring. You can get information about your servers, you know, how many times CPU is going up and down, displays. I was using it a lot. So 5 minutes delay, information free. If you want to see 1 minute, money talks. CloudWatch expanding their services a lot. Now they are saying, you know, you can send your custom metrics from your application. For example, you want to know if your function, how many times being called during the day, you send metrics to CloudWatch. So you can make a kind of central information tracking on for your application as well, not only infrastructure for your application. Netflix developed libraries again for this. You just annotate your function. It's going CloudWatch directly. It's just very easy. And now they are doing, you can send logging as well, all log information to CloudWatch. So they are expanding CloudWatch a little bit more. CloudWatch, you can create alarms based on metrics. You can say if CPU utilization goes up 50%, or if network goes this, send me an email to this, or run this AWS Lambda, lots of different things. CloudWatch is very important, one of the most important cloud features, auto-scaling, when you can scale your infrastructure based on some metrics. I will show you here. So if you get like spiky traffic, you want to launch new service on your service. So you can do with auto-scaling. You define an auto-scaling policy based on CloudWatch metric, or it is readable. If it reaches the alarm threshold, CPU utilization over 75% for 60 seconds, you say add one instance. You can define this kind of scaling policies. You can add actually more than one service as well. Let's say you have 2 servers, you request coming more, and because you got load balancer, right? It's distributed, evenly distributed load. So their CPUs generally going up together. So one of them you say over 75%, for example, you say if it contains like 1 minute, 2 minutes, let's launch another one. So when you launch another one, it just attaches itself to load balancer automatically. So load starts to distribute the other one as well. If your request is coming continuously, that means like 3 servers going 75% again for a certain time, maybe 5 minutes, 10 minutes. And you say, okay, launch another one. So after that, let's say 5 o'clock comes and you want to go home, you sleep, in the midnight traffic is going down. You say, if CPU time is less than 30%, kill one of the server. So when you kill 30% going up, so you kind of balance the CPU. For example, let's say around 50%. So if less requests coming, it can scale down, and more requests coming, it can scale up. This is cloud again. Traditional computing system doesn't allow it.
Can you also do this for per region? For example, China is
It's a good question. In here, everything you do is just per region. You can create rules from one console for all other regions. So data not replicated directly regions. You have to do work. This is auto scaling.
Can I limit the auto scaling for a price? So can I cap it at a price? Because this goes on forever, I suppose.
You can say maximum 10 instances.
Okay.
So,
Max 10 instances,
Yeah.
that's basically capping it. Okay.
yeah, people talk all different possibilities. You know, you can take over.
Can you say don't spend more than $100?
No money, just server.
So you can calculate money.
So we launch an EC2 instance. You know, we click button like Microsoft style. next. You get server. You know, which is not very good model. We don't like Microsoft. And we configure auto scaling or manual processing, which doesn't sound like very automated way. So there's an AWS answer for this. Cloud formation. So in cloud formation, you can define all your infrastructure in one JSON file, and you can run in AWS console. So it just starts everything. So you can kill whole stack. It just done, you know, kill all the terminal servers. So you can automate everything in one JSON file. Already I did before coming to the presentation. I'm going to show you here. Not this one.
How can you verify it before you upload?
I said not difficult question. Next slide. I am doing here marketing, you know, good science. Cloud formation. Oh, I put this here. So this is the JSON. You can define all server types, support instance, you know, how much you want to pay, etc. All the resources can be defined in JSON. This is mappings, resources, parameters. For example, when you run JSON, you can say, I want to parameterize this, running this JSON file. For example, you can define development environment different, staging different, and production different. So when you run JSON, you won't ask questions. So you can, for example, give like dev database, you know, dev load balancer, etc. This kind of information. So you ask for parameters for extra input from the user. After that, it runs. It's called stack. So you can create dev stack, staging stack, production stack, etc. So when it is running now. So when I say terminate action, delete stack, it will kill all servers. So let's say, oh, I want to change, you know, I want to add like not MySQL, now I want to add Cassandra and connect to load balancer, blah, blah, blah. You update your CloudFormation JSON script and say update stack, it just takes the new JSON, look at the difference and create new services and append the existing ones. So you can actually control your existing infrastructure, all the JSONs. When I say automation in the first slide, this is automation allows you to automate all your environment. And also they provide, this is actually end of my slide. I'm going to show you the events. When you run this JSON, for every step, it just creates an event, you know, successful or not. So you can continue your deleting progress, delete complete. Something is deleted. What time? Oh, it's in the morning. Okay. So CloudWatch, you see, it's creating auto-scaling policies, security groups, everything. So it's good for development purposes. You know. So a developer actually, you know, create resources and everything, maintain them. They don't need to know low level details.
Can you go back to the previous version? Like you realize that you've done something wrong, and you wanna revert back to some other, you know, historical configuration that you had made.
AWS doesn't provide this history. You need to think about infrastructure as a code. It is in your repository, Git repository.
Yeah.
So when you wanna make a change, you have to version yourself. You know? It's not like on production thing, you change JSON, upload new one.
Is it integrated with Amazon, this repository, your version control system, that JSON file?
Yeah.
Is it integrated with Amazon Web Services?
Uh,
So when I commit in my changes, for example, is it possible to immediately kick it off?
I mean, this console is actually kind of helper tool.
Oh.
Everything you can do here, there's an SDK. You can write all on your scripts, pull out source code, load the JSON, upload and everything. Options, unlimited. You see what I mean? So AWS doesn't give everything. In general, I tried lots of services. When they launch a new service, always immature. You know, I know the first time of cloud formation, very, very painful. But they just launch agile.
Yeah, it's amazing.
They just basic feature, launch, and get customers to pick, add new features. So when you use now cloud formation, you can say, oh, why they don't do this? Why don't they do this? Because they don't see value. Maybe they don't see the customers not putting feedback.
You can design a course at any time. You can tear down and create from scratch for a class, for example. You can design a course. For example, you want to give everyone different separate virtual machines
Yeah.
for a particular training. I don't know, Java training, for example. And you have 12 people in the classroom. You can create it from scratch, and during the training, a day or two, and then you can tear down for the next class again. It's amazing. It's a vital actually.
I was doing this cloud formation in Qucik scripts in 2012. I was creating load balancers myself, coding, networking, everything. I was launching my service in the scripts, running my performance test cases, downloading metrics, killing the environment. I didn't like cloud formation that time. I said, no, there is SDK. It was really easy, you know, just load balancer, attach this. But now this is becomes more machine, now more professional, you know. But options are limited. I think this is, so you are now cloud expert, certified.
One new question. For your development environment that you just through a script starting your service, so is it charging per hour in that any or whatever amount you restart in the same hour?
Yes, yes.
So you do restart 3 times, you just pay 1 hour cost.
Every time a service starts, 1 hour charge.
Okay.
So, yeah.
So you said you were killing after getting the metrics.
I was paying.
You were paying. Okay.
Because it is performance test case. It is one of the continuous delivery thing, right? When a new feature, you want to run performance test case. Because it is cloud environment, I can create, we can have another continuous delivery session. Every feature, I want to test my infrastructure with the new feature, performance test cases. It should run in cycle. That's why we were creating scripts. You know, every day I was running performance test cases. Company paying the bill, so we don't worry about how much it costs. So it is good practice. You know, all the time we are creating cycles. Extreme DevOps guys, if you look at them, they say, you know, my average production server time is less than 3 days. So one of the servers leaves more than 3 days in production. Because these guys continuously updating servers, killing new servers, updating new ones. Real productions is less than 3 days. They just kind of show them off. Other guys say, oh, we have actually average 14 days. You know. My service a couple of months, you know, just we launch, we never kill the service. But they going extreme, you know, this infrastructure as a code, you know, they automate infrastructure.
Ramazan, may I ask a question?
I'm tired.
As a startup software company, for instance, you will buy some servers, some platform components, and then integrate them, build up an end-to-end software development lifecycle, etc. But this entire small-scale platform, integrated platform, can be bundled together as a product out of AWS.
Platform as a service.
Do they do this as a software development, all-in-one software development platform service?
This is platform as a service.
I mean, do they do this? Is there such a product built
I said cloud foundry, you know, there's open source. Yes, there is a version. Even there is a cloud open source, OpenStack, you know. You can download, you can put a couple of servers at your home, you can create your own cloud infrastructure service. You can do this free, open source, OpenStack. Not difficult, you know, it takes a couple of days.
One other question, I was like, if you have time, if I have credit to do so, just short answer is no. What is the value proposition of AWS in terms of compliance with certain standards or adoption of certain practices like COVID, ISO 27000,
Yeah, I said
or ITIL, etc.
they got over 200 certifications. They are closely following regulations.
Well,
For
no,
example, PCI.
I don't mean that. I have a IT department, and I would like to adopt some certain practices, and I would like to also some of my platforms or hardware to AWS. What is the facilitation value proposition of AWS in terms of my adoption of some practices or compliance with standards?
I think I didn't understand the question.
Well, as an institution, I don't have to, of course, and I cannot always be able to outsource my entire infrastructure, platform services, etc., software to AWS. I may have an entire infrastructure, platform services, and software services as a stack, and I need to adopt some best practices like ITIL or good practices like ITIL or comply with some certain standards. When I transition to use AWS services, does it make it easier for me, or how does it make it easier for me to comply with these standards?
Actually, I think it depends on the standards, right? Which one? I don't know, specific. But already they cover lots of business cases in terms of standard. You can check their website. What kind of certification regulations. One of the, here, for example, if you look at the infrastructure, this is AWS Cloud Cloud. Strictly, United States says no normal business customer can use the data center. For if you want to serve the United States government projects, they don't want any multi-tenant application, even data center. So AWS look at the size of the government and they say it is worth for having a separate region just for government projects. So it depends on, so they cover lots of things. For example, now they are launching a new data center in UK, and there is one in Ireland and Frankfurt. European Union regulation, for example, they say you can't store customer data out of European Union. So they just put a data center if there's a regulation affecting the AWS business. So they are actually responding lots of regulations, but it depends on value. So you need to check. If you have more questions, we can have bring him outside to do for
Just maybe the last one. Can I ask? In HSBC, they start installing PCF internally in the HSBC servers, and then start using them actually. Instead of managing the software, they start using PCF. So the infrastructure, they start using PCF. Does Amazon Web Service provide this kind of solution for like big financial institutes? Because for them, they don't want to expose the data to the data centers outside their company. So
it is actually company decision. If they don't want to store, well, what can we do? Right? So it is another thing people say, I don't want to put my data on cloud. What is the benefit of cloud? I have a data center. I'm not going into global business. For example, HSBC. He said, we got already database in Hong Kong. I got replication data centers. Why do I need to know? So if you want to do cloud business, then you are in the wrong place, right? So it doesn't appeal all customers, which is understandable. But security, in terms of security, I think for me is the same security HFC can provide in their data centers, right? So if you go AWS data centers, they physically protect the data centers very well, 24 hours security guards. And entering the data centers is very strict regulations. I read stories, but they are very strict, accessing the server physically. So after physically you can access the box, you can find the disk, and data is encrypted. So what I mean. Like, already it is secure, you know, what can you do more than AWS does in data center? The same. Well, it's more, I think, company policy, you know. They say we don't want to deal with these kind of things. In the future, maybe yes, but now, let's go outside. Continue maybe talking. Thank you very much for listening.
Very much.